Hi, good morning all. I'm Enrico Casale from Avio Aero, and I'm very glad and honored to be here today, invited by the European Commission to participate to this amazing event of the European Green Week and have the chance to spend the next 1 hour and a half together with the other speakers and with you talking about sustainability and talking about aviation and how aviation is going to contribute to the climate neutrality challenge and the sustainability as the Green Deal target has set and as the European Commission endorsed as the key target for our future investment in technology. So today we will try really to present to you the context in which we are working. So in order to understand how aviation can really contribute to this target, we have to start knowing what the target is and how we can move, and we have to move and play to support the achievement of such huge target that we do have in front of us, a sustainable aviation, a climate neutral aviation. Then we will spend some time looking at the technology, so which are the key technologies expected to disrupt our products, what we are investing on, and how our product is expected to change in the coming future. And the next part of our discussion today, it's related to collaboration, because collaboration is a key element of our success as a community. So today I'm representing Avio Aero, but the challenge we do have in front of us is not only an Avio Aero challenge, it's an aviation challenge. And that's why we have to act as a community, as a one team, to really be able to achieve climate neutrality. We would like today not simply to present our view to you, but to have an interaction with you. So during all the duration of our presentation, a Slido will be open. The Slido has already been open, so you can connect to slido.com, and with the hashtag #UGreenWeek, you can submit questions, and please do it. Please, we want to hear your voice. We want to have your point of view, and we are ready to answer to your question. So all the comments you will raise through Slido, all the questions you will answer, highly appreciated by all of us. So let's start. I would like to, first of all, introduce myself. So I'm Enrico Casale, and I work in Avio Aero in the Advanced Technology Operation Department inside engineering, and I'm responsible of the European New Technology Introduction Program and the Research Network. And as anticipated, I would like to start this two-day session with an overview on why we are here today to talk with you. But before going into the presentation, I would like to share with you a video to make you know something more about who we are as Avio Aero. So please enjoy the video.
The history of aviation. Here at Avio Aero, we know all about it. We've been at its forefront for over a century. It all started for us in 1908 with this amazing piece of engineering, the legendary SAA-75 engine. Since then, we've been continuously designing, building, and improving our products. How do we do it? With a now well-established approach. From the design stage, we take the project all the way up into the air. Everything we design, build, and service at our factories is the result of a process shaped by the highest quality standards, controlled and monitored from beginning to end at every stage. Innovation is what drives us. That's why we have established very profitable partnerships with the most important universities and research centers in the world. A sound approach, which has enabled us to achieve and maintain technological and production excellence at a global level, and to form solid partnerships with the main international players in the aeronautics sector. We believe that to be leaders in such a competitive market, we need to predict and prepare for the future. The digital transformation has opened a new world for Avio Aero, a world which we will face with the same clear, constant goal: to enable the future of flight.
Okay, so I hope you enjoyed the video, and I would start from the last sentence you heard in the video. So we are here. Why we are here? We are here to prepare the future of flight, to build the future of flight. But to do so, we have to understand the direction we need to define for our future. And that's why we have to start from the context in which we are playing. And this is something very well related to the reason why this week the Commission organized this amazing event. And we have to start knowing the problem we have to face. You know, I'm an engineer, and as the majority of the engineer, I like facts, figures, I like root causes analysis. So I want to start from the target. And the target we all have is the global warming increase, which is something, is a reality, you know, is a fact, okay? As you can see, we are really living and facing a unprecedented increase in terms of global warming due to the emission. So it's something we did. It's the issue of our planet. It's something our planet can no more sustain, and we are responsible for that. But we have to understand why this global warming increase is happening and what is the major reason for that. And we can see that there is a direct correlation with CO2 emission. So it's impressive, the growth trend of CO2 starting from mid of last century. And that's what we have to face. So in order really to limit, to reduce and to stop the global warming increase, we have to act immediately on the CO2 emission. But again, we have to know what we have to do. So which are the contributors to CO2 emission? Aviation is part of clearly the mobility industry, transportation industry. And if we look at the numbers, the overall contribution from the transport industry from the transportation, generally speaking, to CO2 emission is something lower than 20%. And inside this 20%, the contribution coming from aviation is 2%. Okay, so 2%, it's our current contribution to CO2. Is it low? Is it high? Well, it's not low at all. It's not negligible. And is not negligible not only considering the current contribution, but expected considering the growth trend of aviation. So we have to be aware about the fact that aviation is a mobility way of transport, is a way of transportation leaving a continuous increase from the last century, from the beginning, I would say, of the commercial aviation. Averagely, we can say that every 15 years, the numbers of people flying, the number of passengers is multiplied by 2. So if we consider that growth with respect to the current contribution that we already have in terms of CO2 emission, is evident that we have to find a way to make this growth sustainable. So we have to find a way to keep on growing, but without affecting our planet. And the figure you can see in this graph, so this growth trend really is not a marketing picture, is the reality, is demonstrated by facts. And aviation is a resilient market. So this growth in the past passed through several crises, and also today that we are facing the worst crisis ever for what concerns the commercial aviation sector, so the COVID-19 pandemic emergency, we are slightly recovering. We are today something less than minus 30% with respect to 2019, so the last, I would say, reference value, last year in the present time we were something close to minus 70%. So you can imagine, you can easily understand how the segment is recovering. So clearly we passed the worst period ever in 2020, not only for aviation. Clearly we are still in this situation, but we are recovering, and therefore this growth won't be stopped by the COVID-19. Why? Because people want to move, because we ourselves as human beings want to know other cultures, want to know other countries. We want to leave our planet, and aviation have to guarantee such volunteer from the human beings, but in a sustainable mood. And aviation is also a resilient market, is a resilient product, also considering the size in terms of GDP, which is comparable to, maybe larger with respect to some of the G20 countries. So you can easily imagine the amount of investment, the amount of people working inside of aviation. And also aviation is also highly impacting on our society. But again, we have to find a way to make our growth sustainable. If we look at that trend, and if we compare with respect to the 2050 target, so climate neutrality by 2050, we have to be aware that in 2050, most likely, the number of passengers flying every year will be 4 times than the current numbers. Maybe not 2020, maybe more 2019. But the point is that we have to find a way to comply with this growth, and the fact that our target is not even to stay at the absolute value behind the 2% of CO2 emission, but we want to be climate neutral. We want to find a way to be climate neutral. The good thing is that we are not starting from scratch. We are not starting now. So already today, we can say that we achieved a huge saving compared to the situation in terms of emission expected in 2050, if we have not started already since decades ago a huge investment on technology, which is basically characterized the whole story of aviation. So aviation is a very, I would say, living sector, really investing in technology since the beginning of commercial aviation. The point is that it's not enough. So even if we already did a lot of things, even if we already achieved a huge improvement in terms of efficiency and therefore emission reduction on our product, is not enough. We have to find a way to keep on investing in technology, but in a more disruptive way, and we have to enable the usage of sustainable fuels rather than kerosene. So technologies and new fuels are the 2 big elements we have to invest in. And we have to do it in a way probably never seen before, or at least few times before in the story of aviation. So to make you having the right perception of how huge such challenge is important to put in the right context. So before then going inside the details in terms of technology improvement, I really would like to try to show you how this challenge is something which really will disrupt the whole way aviation is perceived. So if we consider the current story of aviation, we can simply split in 2 big phases. The pioneer era, so the burn of the commercial aviation, starting from the first commercial flight school, beginning of last century from the Wright brothers, which then, through the introduction of some key disruptive technologies, enabled us to enter in the current era of aviation, the jet engine era. And from the name itself, you can easily understand how this era was enabled by the introduction of a key technology, the usage of jet engine, which then basically enabled us to enter in a period in which the commercial aviation is not more related to few people, is not a niche product, but is a mass product. Everybody can fly, everybody flies. So if you compare the way we are perceiving also the aviation as a means of transportation today, is completely different with respect to 30, 40, or 50 years ago. And that was thanks to a continuous improvement in technology, starting from the introduction of the jet engine plus key other technologies at aircraft, system, and equipment level, which then open us the opportunity to be ready today for a next step. So what we are living today through this need to introduce new disruptive technologies, to have a completely new approach in terms of product innovation, is something similar to what we saw in the past, moving from the pioneer to the jet engine era. So we are now entering what we can call sustainable aviation era. So as the jet engine was a revolution mid of last century for the commercial aviation, the climate neutral propulsion system we are investigating, we are investing in, and in a few minutes we will see something more about that, will enable us to enter in a new era, so the sustainable aviation era. And again, as an engineer working in the aviation, I'm really excited to have a central role, to have maybe not a central role, but to have a role, to play my role inside this wonderful and amazing period for aviation. Very challenging, but we really perceive that we are changing our future. So we are building the future of aviation. So thanks a lot, and I'll pass the ball to the next speaker. So Jennifer, please.
Hello, good morning. It's really an honor to be here today. Thanks, Enrico, for this good introduction. It's like you say, it's really exciting to feel at the forefront of a revolution, because in fact, this is what is happening right now in the whole industry sector, in the whole economy sector, but in aviation in particular right now. So today we're going to discuss together about the trajectory to achieve a climate neutral aviation. We'll look at a really high level into the context and challenges, and try to get a flavor of what is going to characterize the next century. Okay, so let's start a bit with the context. Climate neutral aviation. What are the challenges? What are we talking about? So first of all, a little disclaimer before starting my speech on this. Okay, so in this presentation, I'm going to focus mainly on decarbonization. So on those technologies tackling the CO2 emissions of our engines. However, these are not the only emissions coming from an aircraft. In fact, if we look at our engine emissions in particular, we see that next to CO2, which is a thermal pollutant, which is linked to the increasing global temperature and global warming phenomena, we have also carbon monoxide, nitrogen oxide, SOx, particulate matter, and so on. These are give a flavor of the degree of complexity of the challenge. So next to the decarbonization, we have a broader challenge of climate neutrality, also considering noise emission, for example. But right now, just to keep it a bit simple, we'll focus on decarbonization. So let's look at the global fleet. Let's go clockwise in my graph in the center of the slide. At the smallest, let's say, aircraft we have in our fleet is the commuter aircraft. This constitutes the 4% of the global fleet. It's powered by a turboprop engine, which is an engine with propellers. What we have one step further in our fleet, so increasing the number of passengers and in the mileage, we have the regional aircraft. You're probably more used to this kind of aircraft. Maybe you can fly on one of these when you go from a smaller airport to a larger airport or hub, so to another connecting flight. Next to this, we have the short and medium range aircraft. So there are separate ranges, short range aircraft and medium range aircraft, but together they constitute the narrow body aircrafts. These are, as you can see from the graph, are the most present flights within the global fleet. you probably catch one of these to transfer from large cities within Europe, for example. Okay, so then the largest aircraft we have in our fleet is the long-range aircraft. This is also called wide body. Why narrow body and wide bodies? It's very simple, because when you get inside these aircrafts, you immediately see that the larger aircraft, the long-range aircraft that you get to go from, for example, Europe to the United States, has more than one aisle inside of it. It has a lot of space inside it, whereas the short and medium range are the single aisle aircrafts. Okay, so let's look at how these various market segments, so all these different aircrafts that constitute the global fleet, impact on the CO2 emissions of the fleet. So looking at the pie chart at the right, we can already see there is a tiny slice opening the chart, which is relative to commuter aircraft. So we can immediately say that for a 4% market presence of the commuter, they have negligible CO2 emissions with respect to the total of the CO2 emissions. Moving on, we have the regional aircraft with just a 3%. So it's still being a good guy here. And next to that, we get to really the lion's share, because we can see that the short and the medium range together, we saw that they make up the 71% of the global fleet, and they are responsible for 67% of all CO2 emissions. So this already gives us an idea of what is the market range where we have the highest challenges, but also the market segment that has a lot of opportunities linked to it, because we can really reap the high benefits from here. Also, long-range aircraft, which are present for 12% within the global fleet, constitute one third of the CO2 emissions of the whole pie. So we need to keep an eye on this guy as well. Okay, so let's move on. What are the decarbonization enablers in our challenge? So we have presented what the challenge is and the various degrees of complexity we have. Then we have, fortunately, some cards in our favor. Right now we are looking at these 4 boxes. These are the solutions that we have to, from a technology standpoint, that we have to match together in order to solve the puzzle of climate neutral aviation. So let's take a little step back. Why do we need to, why is there CO2 coming from an engine? Again, this is very high level, so, but just to get this straight. So every time we have a combustion inside an engine that uses a hydrocarbon as fuel, the chemical reaction will give CO2 as a byproduct of it. So what can we do about this? We can either we can enhance our combustion or the way we burn and the way we operate this engine through efficiency improvements. We can change the aircraft architecture, the engine architecture, leaving on one side the combustion and passing to an electrification solution, or we can change what we burn and pass to a more sustainable fuel, or a fuel that is not containing any carbon, to reduce our CO2 emissions or completely eliminate them. So, okay, starting from the yellow box, efficiency improvements. What efficiency nowadays, you saw it from Enrico's slides as well, are 75% more efficient with respect to the engines of the early jet era. So huge improvements have already been made in this relatively new industry. Moreover, each generation acquires something like 15% of efficiency from generation to generation. Right now, however, if we want to reach our target by mid-century, there is more to be done. There is a giant leap that we need to take right now, and evolutionary improvements are no longer sufficient. We need to think outside of the box. And how do we think outside the box? We need to do things that have been never done before. For example, the picture that you see in the yellow box is a disruptive kind of engine. So it's a potential solution, something you can see probably in a few decades from now. You will fly on an aircraft carrying an engine such as this, which is an open rotor configuration. But so let's see if this is potential a solution in the future. But again, it's a balancing act. So let's go on with the other thrusts. Electrification is another disruptive technology. So all revolutionary improvements. And you probably hear about electrification also in the automotive industry. So these buzzwords are probably familiar with you. Again, within electrification, there is a broad spectrum of technological configurations, because the only really CO2-free electric propulsion is the fully electric one. So it's an aircraft running on fully electric engines powered by batteries. Whereas after this, we can look at a various range of hybridization degrees, which do not eliminate the presence of the conventional engine, but have an electrical engine that in mild hybrid configuration helps the thermal engines. But this degree can be increased, and the electrification, the electric motor can gain importance, and so reducing the CO2 overall emissions of the aircraft. What is the main barrier behind this technology that needs to be studied and will be applied in the next years in some market segments? It's for the fully electric, it's especially the battery technology. In fact, the battery's energy density has really improved over the last years, but right now it's difficult to imagine that their power density will be enough to really power high market segments. So what we will probably see in the next years, we'll see smaller commuter aircrafts with carrying full electric technology that will be sort of a test bench for higher market segments, and some degree of hybridization in regional aircraft. Okay, so then let's get to the fuels. So the last thing we can do is we can change what we burn, or yes. So sustainable aviation fuels, or SAF, are fuels that are very similar in their chemistry to conventional jet fuel, which is kerosene, which is fossil-based, but they are not. But SAFs are not fossil-based. They are, in fact, sustainable. They are produced from a variety of sustainable feedstocks, ranging from crop or non-food crop, or e-fuels, biofuels. The important thing in as a feedstock point of view is that it needs to be produced in a sustainable manner. So this is a great challenge behind the sustainable aviation fuels pathway, because we can't just have a cleaner fuel, but then let's say move the emissions from one sector of the economy to another. So we must ensure that all the life cycle in the production of the fuel and its utilization is net zero, is virtual zero in its emissions. Right now, the good news is that sustainable aviation fuels are here. They are ready. They're actually being blended with conventional jet fuels, up to a 50% blending ratio. So they are already able to be dropped in. In fact, SAFs are also called drop-in because you can put them inside conventional aircrafts right now and mix them with the jet fuel and reduce the climate impact of your flights. There is a lot to be done to increase this blending ratio and have airplanes that fly on 100% SAF. The fourth box in my decarbonization enablers slide is dedicated to hydrogen. Hydrogen is a really disruptive change in the aviation sector. So next to what I called SAFs, I called them drop-in. Hydrogen would be a non-drop-in fuel. This means that it requires substantial alteration of the engine and aircraft in order to be used as fuel. The paramount benefit of using hydrogen as fuel is that it allows for a complete elimination of CO2 in flight. So the fuel in this way doesn't contain any carbon, so the chemical reaction won't have CO2 in its byproducts. So this is great news. But there are a lot of challenges behind hydrogen technologies. The main challenge is linked to its volume in particular. If we use it as liquid hydrogen and we directly burn the hydrogen. So if we need to stock hydrogen on a plane, we need to remember that it will need higher volumes with respect to kerosene to deliver the same energetic output. So this, as you can imagine, constitutes some kind of a challenge to fit on an aircraft. So the storage within the airplane needs to be rethought. Hydrogen can also be used as the fuel for fuel cells. Fuel cells share the same barriers that the battery technology that I mentioned before for electrification have. So, but I mean, all of these technologies I've mentioned, we will see them in the next years. And again, they will have to be balanced together. So it's not like each airplane will have one of these. They will be matched together. So probably we could have an airplane going with one electric engine and the other electric engine won't be conventional. Maybe we'll have all the efficiency improvements we talked about before, and it'll be powered by sustainable aviation fuels. So really we have to match all of these thrusts together and solve the puzzle. So putting everything we said together, so putting all our technology improvements and all our little airplanes from the global fleet, the puzzle that I see for the future is the one I'm showing to you now. So we'll have efficiency improvements that will likely produce the higher results in the short, medium, and long-range aircraft. Obviously, every aircraft of the fleet can benefit from some kind of efficiency improvements, but these are the segments where we'll obtain likely the best results. What then the electrification, this I mentioned before, we'll see this in the next years. Full electric configuration may appear for commuter aircrafts or aircrafts anyway carrying a really low number of passengers. And then we'll see some kind of electrification with hybrid configurations on regional aircraft. These will serve as test bench for the higher market segments. Sustainable aviation fuels are probably the technology we're going to see happen quicker than others, and we'll see them really fueling all of our fleet, hopefully, as they can be dropped inside our aircraft as they are. Hydrogen will likely appear in the regional and short to medium range aircraft, but to actually see them fuel a long range aircraft, it may take a while. Right now, this is what we are hoping to see and really what we're putting our energy in, and we hope we'll have really good news to tell you in the future. So thanks for following along with me. And now I'll leave the ball to Stefania. Thank you.
Okay, so good morning, all of you. And first of all, I would like to thank you, the European Green Week organization, to give us an opportunity to speak about what we are doing for the Green Deal from our side. This is a really great challenge that is in front of all of us in this this planet, I would say. Okay, a bit introduction of myself. I'm a mechanical engineer. My name is Stefania Migaldi. I work in Avio Aero since 1999. I would like just to share with all of you a bit of my experience because during my professional path, I also learned a lot about collaboration, which, as I will show in the next slide, is a really key technology enabler. Okay, so I spent my first 4 years in engineering, first 2 years on the design office, 1 year, something less on gearbox. And I saw how much an engineer can be passionate on gears, which was not so easy to understand for me. I was from gas turbine as a university origin, I would say. Then I went in at one of our major customer for 2 years as a technical representative. I was from engineering, but if someone of you already had this kind of experience, or if you will have this kind of experience, you can see that if you are the only one, as I was, as a representative at a customer, it doesn't matter which is your own goal. Everyone from your company will look at you to fix its own issue with that customer. So it was a crazy time, but as usual, really, really nice, intensive, and again, a good collaboration experience. Okay, then I spent almost 10 years in project management, and it's a good position inside large industry because you have a chance to see how all the company works, and it's not an easy task. I had several customers, several programs, pretty different, old program with lots of fleet hours on, brand new product introduction, joint ventures. So many kind of teams, many kind of reaction of people within the teams, several kind of visibility also. Again, always lots of need to become to extend and grow more and more the collaboration skills, which is, I would like to say, at least from my experience, not an easy task, not something so easy to achieve. And then now I am back in engineering. I'm happy, really happy about it. I'm as a research network and emerging technology manager in charge to facilitate, I would say, the connection between needs of Avio Aero and the pretty big research network we have across Europe, with the focus on technology development. And we saw from Enrico, from Jennifer, how the technology development is one of our, main goal to achieve. Okay, so let's go ahead. Okay. And let's see now how collaboration is for us a really key technology enabler. To understand it, we need to think about our major goal now, the sustainability. What we have to do is then making your fly more sustainable. And this is a complex job. Complex because our product must be installed in an aircraft. The aircraft, it's a pretty complex machine. It takes millions of parts, has a durability requirement that are crazy. 20,000 hours of durability, which means that an aircraft has to have 20 from 20 to 30 years of life. And if you think about how much a model car should live, you can feel the great challenge of this requirement. The engine is a complex system. We need a lot of disciplines to be involved in order to develop an engine. Develop an engine takes from 4 to 6 years, going from a concept design to the certification of the engine. Certification means get the possibility from an authority to put our engine flying on an aircraft. And it's not so easy. A lot of tests, a lot of analysis, a lot of people working at the end of the day together, but people many different with goals that sometimes conflict each other. We have engineering guys that are focused on having a product durable, and they want to be sure they will not get damaged during the so long life they must comply. And then we have, for example, let me say production guys, they want to deliver parts, and sometimes these two teams conflict together. That's normal, that's human. That's why we need this pretty big and various network of person collaborating each other for greening. Okay, this is a slogan, but this is not a slogan. This is our must for greening the aviation. Okay, so this is not the full part of the work. We are not just speaking about collaboration and that's it. In order to collaborate, we need to have a clear path, and the path must be effective. So how we work together? We work together following a process. Actually, there are several ways to define the process. What that I want to share with you now is a basic one, the so-called technology readiness levels. So what does it mean, this? Okay, in the previous slide, I commented about how many years we take to develop an engine. This is in the path you can see here, just the very end portion of the path. So the new product introduction. But in order to get there, we need to have proven technology to be used to develop our product. Proven technology means that we need to make innovation. We need to think about new technology. Jennifer listed several of the new technology on which we are working now, but they must be proven, because we cannot start our development with the technology that at the end will be not in line with our expectation. It may cause not only waste of time, not only waste of money, but it can also impact on the safety or impact on the sustainability. Okay, so how we collaborate. Let me go back to my goal. So explain how we collaborate, and let's go back to the network I was mentioning before. The path to get proven technology to reach the right readiness level of technology start from basic principle, from kind of a brainstorming we do to see all the technology on which we can count and we can work on. The first level to verify how able these technology are to fix, to stay with our, to comply with our target, could be sometimes a waste of time. Not always the results are in line with our expectation. So on this portion of on these initial steps of the path, a great key point is our collaboration with the academy, with the research network, with the research center also, and this is for the large industry, but also for the academic world, let me say, a win-win collaboration. We can do innovation, having the support from the academia. The academia can understand and work on product, and that in the future may become part of a product, of a flying product. Then let's go step by step. Next step is selected technology be proven in an environment that is more and more similar to the real one. So we are speaking about demonstrator. To make demonstrator, the collaboration goes from academe more to the other engine maker, other large industry, supplier that are not only short, medium enterprise with innovative approach, but full production dedicated. And with this full-scale demonstrator, we can get a more proven technology level. And so at the end, having this level of maturity reached, we can start work on the development of our product. And over all this path, the attitude to the collaboration is key. It's not easy. As I said, we are speaking about different teams working in different companies that are also different kind of organization, academia, large enterprise, small enterprise. If we do not develop an attitude to the collaboration, always we can have high risk to fail the final goal, because at the end the final goal is get for us good component, good engine able to meet durability and sustainability requirement. It take experience, open mind. We do not be, I would say also generosity, because we have to take care not only of our own goal, but also the goal of our colleagues. It's not easy, but it's great. Okay, now let's go to the our experience we had on Research Network, and let me introduce it with a small video. Okay. This is our European Technology Development Clusters, which is a great network that is coming from years and years of collaboration of our, mainly our engineering community, but I mean, not only strictly design related. We have a great collaboration also from the supply chain side of our organization on production process. Okay, you know, Avio Aero is a General Electric business since several years now, and becoming General Electric, we get the opportunity to have great colleagues across Europe, and all of us have a nice history of collaboration with research institution and university through their territory, so their nation. What we are doing now is leverage each other and connect each other to be well structured as a research network in order to face all the deal we have in front of us. And they are a lot. The research network, and on the left side and in the video as well as, you can see all the institutes that are included right now in the network, that is in any way not a closed community, is expanding based on need and added value that can be provided by newcomers. Okay, this network is structured in clusters, and the clusters are able to face the several needs, disciplines of, I mean, required to develop our products. It's not an easy task, but I mean, I'm really proud to be and to provide some help, some support to the growth of this network, to the work of this network, because competencies and several kind of discipline and kind of party are really different, but they are all people with a strong collaboration approach, able to work together, able to see the final goal as the goal of all the team and all the clusters. And the cluster also, they are not just working together. They are well connected. Some of them are really a lot, and I mean, I'm already seeing a lot of good results, and I've already seen also a great effort that can be provided from all of them to the sustainability goal we have. Okay, I see that time is going on, but we have now the section for your question. Okay, and the first question is for me. What is the role of SME in innovation from a large industry point of view? Okay, is a key role for sure. I was speaking before about discipline. They are a lot, several times. They are well focused on product. We cannot do all of by ourselves, so we need partners that are able and that, I mean, develop an innovation approach that is equal to what we have. So having short and medium enterprise engaged in the research activity since from the first TRL, as I was saying, technology readiness steps, it's key, because we can have from them right attitude. They can understand our need, and they can be able to provide the right product, the right solution in a timely way as well. So for sure, he have SME involved since the beginning. Okay, so this is again for me. How can the university and research and development institution join your network? If they can, sure they can. As I was saying, our network is open. Sometimes we do scouting within the university, because we have gaps. We can discover also gaps based on the need and the clarification and experience we get. So new university are welcome, research center are welcome as well. Of course, they need to fit within our network and be able to close the gap. Otherwise, it will be just waste of time for all of us, but we are definitely open. Okay, so let's see the next question for. I will take also this answer. Okay, is it time for airframer and aero engine makers to work better as a team, or for new coalition like in the car sector? Okay, I don't know about car sector actually, but yes, for sure, it's time to have a deeper collaboration between airframer and engine maker. I don't know if you remember one of the images in the technology readiness slide from my presentation. It was an engine with a distributed propulsion system. What does it mean? It means that distributed propulsion imply more and more integration between engines and airframer. So in order to get it, we definitely need to be more connected and to find out a way and a process to start collaboration in a deeper way in an earlier phase of the life of the technology maturation. So that's definitely yes, the answer on this question. Okay. Yes, I will pass for this one the ball to Enrico.
Okay, thanks, Stefania. So are airplanes more polluting than other transport? Okay, quite. The question seems easy. The answer is not at all. If we compare airplanes with the other transportation means, airplanes or aviation is not the more polluting one. So, for example, if we compare, trying to compare Apple with the car industry, for example, so with automotive, aviation in terms of CO2 emission per passenger per kilometer is 2 times lower than automotive. That's just an example. So it's not the most polluting means of transportation. Clearly, if we compare the aviation, for example, with respect to trains, okay, trains are zero emission by themselves because are based on the usage of electricity. But we have to consider many other parallel elements which are impacting in terms of pollution. So for example, train, okay, electricity. But where does the electricity come from? Is it a full green electricity or is not? Because if it is not, again, we cannot compare Apple with Apple. Infrastructure. So train, cars need a huge infrastructure because we need to use, I would say, such vehicles on the field. Aviation has not the same need in terms of infrastructure. So it's not easy to give a clear answer to that because we are really comparing transportation vehicles which are hugely different one with respect to the others. But if I consider the current feeling that many people have on aviation, perceived as really the bad guy, so the one polluting more, well, it's not. I can. We have again facts and figures. We have to start our assessment, to make our analysis based on facts and figures. And facts and figures demonstrated that aviation is today not green, or not as green as we want to do. And we just spent 1 hour to describing to you what's the challenge we have in front of us and how we are ready to fulfill it. But it's not absolutely the bad guy in the field. And then I would jump to the next question, which is: military have always fueled innovation. Same here. Okay. Yes, it's right. It's not only for aviation. I think that for the majority of the innovation in many products we are using every day, the original source was military investment. So military was really the first, I would say, actor in terms of boosting the innovation. Also, the jet engine introduction I described you before in really with few words on the history of aviation is something coming from military application. So it's not so strange. Today, the situation is quite different. So today, the challenge is really a challenge coming from the society, is really a challenge coming from the way we live today, our planet, and therefore is not something coming from any military priority. It's coming from us. It's coming from the people. And that's a new thing. And that's why it's so important to cooperate. It's so important to have this collaboration environment as described by Stefania, and we believe a lot as Avio Aero in collaboration. We need to act as a one team because we won't have the same support that in the past we had from the military investment. Clearly, the institutions are key in helping us in reaching such target, in fulfilling the climate neutrality. So we will need the support from the institution, but the simple fact that today we are here, it's, I would say, to me, is evident on the fact that the Commission is really believing on how it's important to sustain the investment in technology towards the climate neutrality. But as an industry, we have to promote collaboration approach with the university, with research centers, with SMEs, with other industry, with all the aviation community, and acting as a one team. That's the only way we will really be able to achieve this huge target we have in front of us. Okay, then how do you think you're going to afford the challenge and meet the deadline of climate neutrality by 2050? Okay, it's also something very related to some of the information we already discussed today. So the life cycle of an aviation product, as anticipated by Stefania, is quite long. So normally the life of a plane, an engine, is from 20 to 30 years. Okay. So if we wanted to achieve the climate neutrality target by 2050, we cannot introduce into the market, we cannot introduce into the fleet a new product on the 31st of December 2049. So we have to do it much, we have to do it before, much before. That's why we are targeting new product entering into service starting from the next decade. So let's say from 2030, 2035, maximum 2030. That's the only way we really can have an impact on the fleet, and therefore seeing a new product flying in a sustainable way. And that's why we have to invest in technology, but we have to address properly the technology investment with respect to the product expectation, as described by Jennifer. So we have a differentiation, a huge differentiation distinguishing the several product demand and the technology offer. To do so, we have to accelerate, we have to invest, we have to invest together, we have to start also implementing the technology that we already have in the current product. We have to enable the usage of alternative fuels because it's also an important opportunity in terms to retrofit the current fleet. So we are going to afford the challenge and meet the deadline, really trying to offer into the market new sustainable aviation product starting from now through the usage of alternative fuels, and having new completely disruptive products starting from 10 years from now, I would say, in the bigger area segment, product segment really impacting in terms of CO2, so from the regional upwards. Okay, then I think also the next one I can answer to that is the zero pollution target to be applied to all segment, military too. Okay. It's challenge, it's our challenge. So clearly zero pollution could be achievable. I don't want to say easily, but probably is more close to us if we look at the smaller market segments, so general aviation, commuter, where full electrification can be the solution. And is becoming much more complex and therefore also far from us if we are going up to the size of the airplanes and to the power of the engines. And that's why it's also important to promote in parallel technology disruption in terms of product, integrated product between the airplane and the engine and all the equipment related together with the SAF. Because, for example, SAF can be the closer solution in front of us, but it's depending on many issues which are basically outside the direct control from the aviation community. So we have to produce SAF, we have to produce in having the right capacity, but also in an economical, effective way. Military too. Is not clearly the first target. So the first target is not to act on the military aviation, is to act on civil aviation. But clearly we could have an exploitation. So new technologies, climate neutral solution applied to the commercial aviation could also have an exploitation to military, which related to the previous question, it seems strange because it's like the opposite with respect to what we are used. So this time is not more the military offering new technology to be used in I would say our daily life, but is the commercial, is the civil investment in terms of technology that could support also military technology to become green. Okay, next one is, do you think traveling by air is going to become more expensive and limited in the future? Let's start from the last sentence. So limited in the future, no. I think that we do not want to limit aviation, and that's why we are investing so hugely in climate neutrality technologies. So we want to make this growth of aviation sustainable. And if we will succeed in that, we won't limit the opportunity to travel by air in the future. That's absolutely what we do not want to see. Any limitation from the movement of the people, mobility of the people using planes. Become more expensive. Okay, I'm not an airline representative, so it's not easy to me to answer to the question, but in our perspective as engine maker, as an industry providing the final product to the airlines, our target is not to affect their business plan. So we want, frankly speaking, we want to sell engines, and to sell our engines, we have to guarantee that our engines are not impacting the operative costs of the airlines. So we have to be effective in terms of SFC, so fuel consumption, and that's absolutely something well aligned with the target of sustainability. We have to be effective on the cost, and that's why it's also important to invest not only on the new technology, but also on the production technology that will enable our shops to produce such new product in an effective way in terms of costs. And everything is to offer to our customer, which are the airline, a product comparable to the state-of-the-art product in terms of operative costs. And that's why I don't expect that then the airline will need to increase the price of the ticket. But again, maybe it's better to ask this question directly to someone from airline representative, but that's not my perception. Okay, transforming aviation is also transforming way we use airplanes. Is it time for a travel slowdown? I think is something I've already answered with the previous question. So no, that's not our purpose. We want to transfer, we want to disrupt our product in terms of being more effective for what concerns the emission, so to be green, but we do not want to disrupt the way people are using aviation as a means of transportation. Not at all. That's not our purpose. And I think it's not what our society needs. And then zero emission. Is it an accomplishable mission or just a slogan? I think we really demonstrated through this session today that, well, it's not a slogan. We are investing hugely in that. You have to consider that the development of a new engine, starting from the technology demonstrator up to the industrialization, so the several phases shown by Stefania, is a huge investment. We are really talking about billions of euros invested there. So it's huge. And we are ready to invest all this money. We are ready to spend our resources, to spend ourselves in this challenge, because we really believe that is an accomplishable mission. And it has to be accomplishable because we want to protect our planet, and we want to do it sustaining the growth of aviation. So it's not a slogan at all. Okay, then next question is more related to technology and sustainable solutions. So I will pass the ball again to Jennifer.
Okay, so what is going to be the first technology or sustainable solution that you think will be adopted in the next future to travel by air? Okay, so I probably mentioned it before, but what we'll likely see in the next years is the presence of the sustainable aviation fuels in our aircraft. I think this is going to be advertised in some way, so we are going to be able to see this as customers in an airline, as passengers. But yes, really this is the most ready solution, the drop-in SAFs. So this will probably really experience as passengers. Then what is most likely to emerge in the next decades or so is the electrification of the smaller aircraft segments. I think these are the ones we're likely going to see in the near future. Okay, so I guess all of these are technology related, so I'm just going to get these last questions. Okay, isn't hydrogen a dangerous propeller for air transport? Okay. And I also see, why is electrification so challenging in aircraft? How are they different? Okay, I'm just going to get two questions together, so the first and the third, because I think that the answer to these questions is related in the sense that both electrification and hydrogen are completely different technologies, and they have their own technology barriers, okay, their own challenges related to the specific technology, but they share a safety challenge. And so this is what brings them common, and what this is the commonality between them. So why is it different? Why is putting electrification or hydrogen on an airplane more challenging than putting this on a car? Well, theirs is really a safety aspect. Well, really, to boil it down to a very simple consideration, planes have to fly and cars don't have to fly. This doesn't mean that cars don't have their requirements, which they of course have, but in the end, really having something up in the air requires some thought about it, you know? So it's not like if there is some sort of problem with your electric engine or hydrogen fuel, you can just, okay, move to the side and see what's happening. So you really, you must be really sure. And what is a good thing about the aviation field is that really safety is paramount. Safety is, so we're talking about the environmental challenge, and that's all good. But we need to remember that when we speak about aviation, safety is always the same thing, is always the first thing. So we have now the goal of safety and of environmental benefit, but safety really remains the main goal. So no, it won't be a dangerous, so for hydrogen, it won't be a dangerous propeller for air transport, because if the engineers put it into technologies and the technologies is feasible, you have nothing to worry about from that point of view. And for electrification, the main difference from a technological standpoint from the automotive sector, I guess it's related again to the difference between an airplane and a car. For example, if we consider a fully electric aircraft, we need to have a battery fueled engine, okay? So based on current developments of the electric technologies, we would have to fill our airplane with batteries and probably not getting any passengers on the airplane, because it would have to transport the batteries it needs to fly on. So really there are requirements on weight, maximum takeoff weight, which aren't present in some vehicle that is going on the road. Okay, so I think I got these two out of the way. And the last one, I guess I already answered this one as well with discussing about the SAFs. So yes, I think maybe we're also short on time, so I guess I'm going to end here. So thank you very much for these questions.
Okay, so I think we are at the end of the today's section. Thanks a lot for, I would say, being patient and having heard all the this session today. To conclude, again, I think we all are really proud to work into aviation. So I speak myself, my personal perspective, but I'm pretty sure that also Jennifer and Stefania could say the same. So we are really excited about the challenge that we have in front of us. We are ready to face it. We are happy to work into aviation, to see all these new technologies and to trying to give our contribute to this climate neutrality challenge, which is really something we have all to believe. So it's feasible. We believe that it's feasible, and we will succeed on that. And thanks again also to the European Commission for having organized this Green Week event. I think is absolutely appreciated by the being a citizen of Europe, to see that the European Commission is so sensitive on this aspect, on the climate neutrality aspect. And I really hope that today we succeed in presenting what's the view from the aviation perspective, which is not only the Avio Aero view, but is really, I would say, I hope, something recognized by the whole aviation community. That's why we are really ready to prepare our future, and we are really ready, I would say, for clean aviation. So thanks a lot, and enjoy the rest of the European Green Weeks.